Okay, hello all. Let's start our new section. Section 1.5. Let me put the number here for you. 1.5 is quadratic equations. Now, let's discuss what is quadratic equation. Quadratic equation, or the second name, the actual name, it's a special name that it's given to these equations. We call them quadratic. Also, you can call quadratic equations second degree equations. But no one calls them second degree equations, polynomial equations, second degree polynomial equations. It's too long, no one calls them second degree polynomial equations. Simple name, quadratic equation. Which kind of equations are quadratic equations? Any equation that is in the form of a x squared plus bx plus c equals 0, we call it a quadratic equation or a second degree polynomial equation. Why second degree or why quadratic? We have our variable has an exponent of 2. It's squared. That's why we call it quadratic equations. In this general form that I'm writing for you, a x squared plus bx plus c, a, b, and c are numbers. Only x is your variable, correct? A, B, C are numbers, only x is your variable. And you have to remember that A cannot be 0. Why A cannot be 0? Because you see in the general form, which is ax squared plus bx plus c equals 0, if I plug in A 0, it will be 0x squared. And 0 times any number is 0. It means you will end up with bx plus c. And if you see bx plus c equals 0, it's not anymore quadratic, it's linear, right? That's why A cannot be 0. B can be 0. C can be 0, but the only number cannot be 0 in these equations is A. A cannot be 0. That's a kind of general information about quadratic equation. Numeric examples, for example, 7x squared plus 2x minus 10 equals 0. I call it a quadratic equation. Or x squared plus 10x, let's say plus 16 equals 0. I call it a quadratic equation. And the first one, your A is equal 7, your B is equal 2, your C is equal negative 10. In the second example, your A is equal 1 because you have 1x squared, right? Your B is equal 10 and your C is equal 16. Or another example, x squared minus 9 equals 0. Your A is equal 1. Your B, do you see bx here? We don't see bx. It means my B is 0 and C is negative 9. Or maybe x squared or 2x squared plus 4x equals 0. Here, your A is equal 2, your B is equal 4, but your C is equal 0. You don't have a constant term, correct? In all these numeric examples that I put for you, I put like when B is 0, B can be 0, C can be 0, or all of them can be number, but never, never, A cannot be 0, because if A is 0, it means you are not dealing with quadratic. Basically, you are actually dealing with linear equation, correct? Now, when you learn uh, what is a quadratic equation, when we have enough knowledge, what is A, what is B, what is C, let's start slowly solving the quadratic equations. The first method, let me put here first a topic for you. I prefer to change my view to the line view. Okay, let's put a new topic here, solving quadratic equations. You can solve a quadratic equation at least in 4 different methods. But any method that you are using to solve a quadratic equation, the answer will be the same, correct? Let's start with the first method that we are using. We are solving a quadratic equation. Our first method is factoring. We can solve some quadratic equation, some of them. Of course, when we talk about factoring, we know we can factor some polynomials, not all of them. There are some of them that you cannot even factor. If we can factor, we can solve a quadratic equation. Let's start with the example. Example number 1. For example, they're asking you to solve by factoring. X squared plus 9x plus 20 equals 0. Usually, when you solve a quadratic equation, you get 2 answers for x. You get 2 answers for x. Correct? And when I solve this, because some of them, they have 2 answers the same. Some of them, they have 2 different answers. Some of them, maybe they have no solution, correct? Later, we will I'll explain which type of solutions that you can get. This is another topic that I will discuss. Right now, our focus is how to learn how to solve a quadratic equation, but I explain it because you will see, oh, I end up with 2 answers. What is this 2 answer? Usually when you solve a quadratic equation, you end up with 2 answers. Okay, the method name is the factoring. What I do, my first step here is I'll try to factor this polynomial, and I had a really short lecture for you how you can factor a trinomial or a polynomial, correct, with 3 terms. Of course, you see, I'll take the square root of x, I'll put in this parentheses, and I'll put in this parentheses x and x. Possible factors of 20. Possible factors of 20 is 20 times 1, 2 times 10, 4 times 5. Now, which pair, if I add, gives me 9? Of course, 4 and 5, right? Or maybe you use this method, the cross method that you learn at the school. I'm not going to stop you to do not do that. Which way is easy for you? Just factor, correct? What are my factors? 5 and 4. Positive 5 and positive 4. Now, what to do after this step? There is a principle which we name it the zero product principle. The zero product principle. What zero product principle is? Zero product principle explains to you, if you have two numbers, for example, A, and you multiply this number with B, and the resulting product, the answer is zero. When you multiply two numbers and you end up with zero, it definitely gives you an idea that one of these numbers are at least zero, correct? Maybe A is zero, or maybe B is zero, correct? We call this principle the zero product principle. Now, we are using this principle to solve this resulting equation after we factor. How? I'll explain it here for you. You had x plus 5 times x plus 4 equals 0. If I think that my first parenthesis is A, and my second parenthesis, if I name it B, I have A times B equals 0, you see? Then I can apply the zero product principle, then immediately I can do this. I can write x plus 5 equals 0, or x plus 4 equals 0. I know in the past, maybe your teachers or told you that, oh, when you have two parentheses, when you come to this stage, immediately set each parenthesis equals 0. Correct. No mistake. Yes, that's the rule. But here I introduced that because it's college algebra as the reason why we are doing this, because we have the zero product principle, correct? Or in an easy language, like always they told you, set each parenthesis equal to 0. Then solve them. X plus 5 equals 0. Of course, if you want to solve it for x, you will subtract 5 from both sides. It means you will end up with x equal negative 5. And here, if you subtract 4 from both sides, correct, you will end up with x equal negative 4. And you see, you end up with two answers. And these are the solutions of the equation x squared, what was our original equation? X squared plus 9x plus 20 equals 0. It means if you replace your x with negative 5, or if you replace your x with negative 4, the both sides of the equations becomes equal to each other. Right? And we call these two numbers the solutions of the given quadratic equation. To be honest, it's way early, but if I want to explain it to you, if here is negative 4 and here is negative 5, negative 4 and negative 5 on a Cartesian coordinate system, it means your graph is actually passing the x-axis or intersecting the x-axis at negative 4 and 5. Actually, the solution for a quadratic equation actually represents the x-intercept of the graph. It's a little bit early. We will discuss it fully when we are dealing with functions, but soon you will see in the next part of the lecture, or if you open your book, they even show it on the graph. That's why I tried to explain for you that the solution for a quadratic equation means the x-intercept of the graph. Correct? Example number 2. x squared, I'll copy this one from your book, minus 7x plus 10 equals 0. First step, I will try to factor x and x. Possible factors of 10 will be 1 times 10 and 2 times 5. Because remember, because your b is negative, then your numbers should be different sign. One of them should be negative, one of them should be positive. The bigger one should be negative, the smaller one should be positive. Now, which pair, when you add, it gives you, sorry, both should be negative, not positive. Both should be negative. Now, which pair gives you negative 7? Of course, negative 2 and what? Negative 5. Then I will write here negative 2 and I'll write here negative 5. Now, using the zero product principle, I can write x minus 2 equals 0, and I can write x minus 5 equals 0. And if I solve this one, I'll add 2 to both sides. Then these two cancels out, x equal 2. One of the answers, and here I will add 5 to both sides. And if I solve, x equal 5 is my second answer. Correct? Let's do another one. But for all of them, I'm using the factoring method. 4x squared minus 2x equals 0. You see here your c is equal 0, but still you can factor. Remember the first factoring that I talked about, the GCF factoring? What I do, I'll use the GCF factoring here. It means I look for the common term. What is common between 4, or what is the GCF between 4 and 2? Definitely 2. What is the GCF between x squared and x? I told you to take the lowest exponent. It means 2x is your GCF. Now open a parenthesis. 4 divided by 2 gives you 2. X squared divided by x gives you x, minus 2x divided by 2x gives you 1 equals 0. Now, using the zero product principle, I can write 2x equals 0 and also 2x minus 1 equals 0. Here, divide both sides by 2. X is equal 0 over 2 gives you what? 0. And if I solve this one, first I'll add 1 to both sides. Then 2x equals 1. Now divide both sides by 2. X is equal 1/2. 2 solutions. Correct? Let me do another example for you. I don't know which example, 4 or 5. I'll name it 4. X squared minus 9 equals 0. If you are really good with factoring, by looking to the problem, you see you have a perfect square here and you have a perfect square here, and the sign is in between is negative, then we call this one what? The difference of the squares. Immediately you know what to do. Open 2 parentheses, square root of the first term in both, then one of the parentheses positive, one of them negative, and square root of the second term, which is 3 in both. Here you go, you factor. X plus 3 times x minus 3. Now set each parenthesis equals 0. X plus 3 equals 0. It means x equal negative 3 if you subtract 3 from both sides, right? And x minus 3 equals 0. It means from here x equal 3. 2 solutions for your problem. Correct? I did like 4 examples for you. If you want to see more examples, I think there are a few more in your book that you can see. It's not a big deal. You can solve, correct? This was the, you can check your book and practice more with more examples. Of course, I assign few problems for your homework and you will get enough practice. That was the first method that you can solve a quadratic equation, correct? That you can factor. Second method, we call it the square root property or solving quadratic equations by the square root property. Square root property. What is first the square root property? If I have u square equals a square root of, for example, let's name it like what the way that they did in your book, u square is, what happened? Something happened. I cannot close this. Okay. If I have u square equal d, for example, 2 square equal 4, then if I take the square root from both sides, the square root of u square will be equal plus minus square root of what? D. And here, square root cancels out with the sign. It means your u is equal plus minus the square root of what? D. Or in this numeric example, if I take the square root from both sides, the square root of 2 squared equals plus minus the square root of what? The square root of 4 equals plus minus the square root of 2, correct? Which these two cancels out and you end up with plus minus 2. We call this rule the square root property. Why I explain it and where we use it. Usually, when you solve a quadratic equation by the second method, which is the square root property, we solve these types of quadratic equations if they are in the form of a x squared plus c equals 0. It means when your b is 0, when you don't have x, you only have x squared and constant. We use this property to solve those problems. Correct? Because it's really fast to use this method. It's really fast to use this method. Correct? We use the square root property to solve those types of problems. I'll start with different examples to explain it more for you. Example number 1. For example, they're asking you to solve 3x squared minus 15 equal 0 using second method, which is the square root property. Steps, how you should deal. Step 1. And step 1, always move your constant to the right side of the equation, and the term that has x squared in it, isolate it on the left side. It means here, I will first add 15 to both sides, which I'll end up with 3x squared equals 50. Step 2. If the coefficient of x squared is not 1, you see a number here, you have to divide both sides by that number. If it's 1, you don't have a step 2. If it is not 1, you see a number there, you have to first divide. Remember these steps, please, because on a test day, I see students are immediately taking the square root from both sides after step 1, and their answer goes wrong. That's a wrong answer, correct? Step 2, divide both sides by the coefficient of x squared. It means I'll do this. I'll divide both sides by 3. Then I can write x squared equals 15 divided by 3 gives me 5. Step 3. Oh, let me change it to red color. Sometimes I'm using different color in my lectures. Please, please, if some of you have problem with colors that you cannot see or it's bothering you, a special type of color, for example, red, green, or something, send me an email and let me know that you have problem with that color. I will avoid using that color in my lectures, correct, when I'm writing. But if you don't have a problem, I usually try to use colors to show what I'm doing, correct? Now, step 3. In step 3, apply the square root property. What does it mean? It means take the square root from both sides. Square root of x squared equals always first put plus minus sign, and I already the reason why plus minus sign, because you know the square root of a number can be 2 positive numbers or can be 2 negative numbers, correct? Now, these 2 cancels out, x equal plus minus square root of 5. If you have the square root of the number, take the square root. If you don't have it, keep it in this form. It means your step 4 is actually, solve. After you took the square root, solve and simplify. Correct? These are the steps when you use the square root property. Let me do another example. Then I may stop the lecture for you, correct? X squared minus 9 equals 0. Example 2. Even I solved this problem in factoring method. But here again, you can use the square root property. What you do, your first step, add 9 to both sides. Then you have x squared equals 9. You don't have a step 2 to divide by something, correct? Because the coefficient of x is 1. Then what you do, you jump to step 3. Take the square root from both sides. A square root of x squared equals plus minus a square root of 9. This square root cancels out with the square sign. It means x equals plus minus, what is the square root of 9? The square root of 9 is 3. You see here you have two answers actually. One of the answers is 3 and one of the answers is negative 3. Some of you may ask why I'm doing this. What is the reason behind? Let me explain to you. This is actually the topic that we discuss it in intermediate algebra. The square root of a number means if you write it as a rational exponent, a number to the power of 1/2. Now, if you have the square root of a squared, it means a to the power of 2 over 2. And here, if you simplify 2 with 2, you end up with a. We are not going this long way. That's why I always just cancel the square root with the square under the square root, and I'll just write x, correct? But that's the reason behind. Another example, another type actually. Sometimes it's good to do these types also with the square root property. For example, x minus 2 square equals 6. You see, at the beginning, when I explained to you, I told you usually we are solving the problems that's there in the form of ax squared plus c equals 0. We use the square root property, but this one is not that. Actually, you have bx also. But look at this side. Your square is on the top of a parentheses. It means I see my parentheses as a one term. Then the easy way is to do this. Take the square root from both sides immediately. The square root of x minus 2 all square equals plus minus square root of 6. Here, a square root cancels out with a square sign, then x minus 2 equals plus minus a square root of 6. Now, solving for x, I will add 2 to both sides. Then x equals 2 plus minus a square root of what? 6 to answer. Correct? These were the two methods to solve quadratic equations. There are the other two methods. The third one is using completing a square to solve a quadratic, which is a long method. I will discuss it for you in the next lecture, in the second part of this video. And the fourth one is using the quadratic formula, which most of the students, they like it as long as they remember the formula. You can solve quadratic equations. I'll stop the lecture here because I don't want to explain all four methods in one lecture. It will be too much for you. I'll stop it here and see you all in the second part of this video.